This is Chapter 1, Introduction to Statistics. Section 1.1 covers statistical and critical thinking. Statistics is a science of collecting, organizing, and summarizing and analyzing information and data to draw conclusions. It also provides a measure of confidence to any conclusion. So why do we need statistics? Statistics is widely used in all different areas of our life. You'll see it in business, you'll see it in sports, you see it in medicine. So mathematics is different than statistics. So mathematics, as we went through your previous courses, you were given some kind of equation, you had to solve it or something along those lines, and you got an answer, and you could always check it in the back of the book to see if you were correct. Versus this, with statistics, we're going to collect data and draw a conclusion, we're going to do a study, and then we're going to be so much confident about our results. So we're not going to be 100% confident about these results, but we might be 90% or 95% confident. Next, we have a bunch of definitions here that are all ones that we should have memorized for our Unit 1 exam. So the first definition is population, which is an entire group that's being studied. Individual is a person or object that is a member of the population being studied. We have a sample, which is a subset of the population that is being studied. Census is an attempt to collect data from the whole population, and we try to do that every 10 years in the United States. And then data is the collection of observations. Datum is a single data value. And then sampling method is a procedure used to decide which individuals would be included in the sample and how they are going to be picked from the population. And we'll look at different sampling methods in a little bit. So the first example that we have says fill in the blanks. So the first one says the blank is the collection of all cars owned by all faculty. And the second one says a blank is any subset. That subset is our keyword here of the population. Say cars owned by the mathematics department. So the first one that we have is going to be that the population would be collection of all cars owned by all faculty. And then when we deal with a subset, we are talking about a sample. The next step here is the process involved in a statistical study. And this is going to be to prepare. And this is how we are going to, when we come to the end of our semester, we'll be collecting and creating our own project. So prepare, we would have to figure out what the goal of the study is, figure out where we are going to collect our data. It needs to be reliable also. And then what sampling method we'll be using. Next, we're going to analyze our results. We're going to have to graph, explore the data, look for outliers, statistical summary of data, how is the data distributed, and apply statistical methods. And then last would be our conclusion. We have to have that level of significance placed on there. So this kind of summarizes the whole entire semester that we're going to be doing in this course, but kind of talking about the process that we'll be going through. So the next thing that we have is voluntary response sample, or self-selected sample, is a sample in which the respondents themselves decide whether or not to be included. Statistical significance, we hear a lot of. This is when a result is very unlikely to occur by chance. 5% or less is usually our cutoff that we use. And then practical significance is going to be, are there differences between the samples big enough to have any kind of real meaning? So we have some pitfalls to analyzing data. So I'll let you guys look through those on your own. And then we get into some mathematical parts of this. A lot of times students struggle with working these out with percentages and converting decimals to fractions and things along those lines. So the first example here says simplify, and it says 6% of 1200. So writing 6% as a decimal, now this is 0.06. Of is that multiplication, and we're going to multiply it times 1200. So working this out on your calculator, be an answer of 72. Part B says to convert 0.347 to a percent. To convert this to a percent, we just move our decimal point twice to the right, and we get 34.7%. Don't forget your percent symbol. Next is converting 2/5 to a percent. You can divide this on your calculator. I will go ahead and say that 2/5 on your calculator when you divide this would be 0.4. And again, just like what we did in part B, we're going to change this to a percent. So doing that, you're going to move your decimal place twice to the right. In that empty space there, we do put a 0, and this works out to being 40%. And then the last one that we have here says convert 89.2 to a decimal. So in order to take your percent and convert to a decimal, we're going to move our decimal point this time to the left twice. So we're going to get 0.892. And if you have additional questions in regards to percents, fractions, or decimals, make sure you reach out to me or to our Marks Center for additional help. The next example that we have says determine what is wrong with the example. So part A says in a USA Today online poll, 951 internet users chose to respond, and 57% of them said that they prefer drinking bottled water instead of tap water. So again, it says what is wrong with this example. The problem with this example is that people are given an option to respond, and that is called our voluntary response. And the problem with the voluntary response is that it does not accurately represent the population that we have. Since we're not collecting data from everybody in our sample, we're only collecting from those that are choosing to respond. It's not a very good group, a good sample that we would have here for this study. And then part B says in recent years, there have been a strong correlation between per capita consumption of sour cream and the number of motorcycle riders killed in a non-collision accident. Therefore, consumption of sour cream causes motorcycle fatalities. Just because there is some kind of relationship here between motorcycles deaths and sour cream consumption does not mean that that sour cream is causing these motorcycle fatalities. So association, or that kind of relationship that we have, does not imply causation, does not imply something to happen. And we see this a lot with other things too. Just because there's some kind of relationship does not mean it has to imply that it's going to happen. The next example that we have says, USA Today reports results from a Research Now for Keurig survey in which 1,458 men and 1,543 women were asked this: in a typical week, how often can you kick back and relax? So part A says among the women, 19 responded rarely, if ever. What is the exact value of 19% of the number of women surveyed? And is this result the actual number, and explain? So it's 19% are responding rarely, if ever. And the total number of women that we have is 1,543. So to work this out, we're going to multiply our 19% as a decimal, which is 0.19, times the total number of women, which is 1,543. And working this out on our calculator, we do get a decimal answer. So I'm going to write down 293.17. So we can't have this 0.17 of a female. So we're going to have to round this a specific way. And so that is not a complete woman that we have. So it's going to be 293 women. Part B says among the men who responded, 219 responded with rare, if ever. What is the percentage of men who responded rare, if ever? And again, men we had surveyed was 1,458. And so 219 out of the total number of men that responded in the survey was 1,458. Working this out as a decimal, we get 0.19. 1504. When you are doing homework or on an exam or on a quiz, it will be stated on how many decimals to round certain kind of answers, so make sure you look for that. And so let's go ahead and round this to a whole number percent. This is going to work out to being 15%. The next section that we have is section 1.2, which is types of data. Few more vocab words that we're going to have. We have parameter and statistic. So a parameter is a numerical measurement describing some characteristic of a population, whereas a statistic is a numerical measure describing some characteristic of a sample. So the example right below this says, suppose 67.3% of students at a college are taking at least one mathematics course. This value represents a blank because blank. So it's, again, 67.3% of students at the college. And since we're talking about everyone at the college, that is going to be from a population. So this is going to be a parameter. And the reason why is because this is discussing a population. So it's about a population. Part B says, suppose we sample 100 students and 70.1% have at least one mathematics course. Since we have a sample, we are now dealing with the value is going to represent a statistic. And the reason why is because it's discussing, so it's about a sample. The next set of vocab words that we have here is qualitative or categorical data and quantitative data. So qualitative data or categorical data allows for classifications of individuals based on some kind of characteristic, like hair color, ethnicity, type of car, day of the week, whereas quantitative data provides a numerical measure of individuals such as weight, height, GPA, and temp. And so again, we are discussing measurements here, and these are going to be numerical. So next example right below this says to classify the value as qualitative or quantitative. So first one that we have is marital status. And since we are dealing with marital status, which would be married, single, divorced, widowed, those are going to be categorical data that we're talking about. So this is an example of qualitative data. And these words are going to be shown throughout the semester, so a good understanding of these would better help you with the whole entire semester. Part B says the number of hours a student sleeps per day. Since we are talking about a numerical value of number of hours, and that would be our quantitative data that we're talking about here. Part C says the cost of a new car, which again is a numerical measurement. We can measure it, and it's numerical, it's a number. This is also going to be quantitative. And then part D is the number on a soccer player's jersey. And yes, it does say number, and I do understand that a quantitative data is numerical, but we don't use those numbers to measure anything. There is the idea of different numbers representing different positions on a field. So we can just go ahead and pretend like this is for recreational soccer. And so if you have a good understanding of soccer, understanding that this is just rec soccer where kids select their own numbers. So because it's a numerical value, it doesn't have any kind of measurement since it is a rec soccer league that we're talking about. And so this is actually an example of qualitative data. The next set of vocab words that we have is discrete and continuous. So a discrete variable, this is going to be a quantitative variable that has a finite or countable number of possible values, such as the days of the week, the number of students in a class, pages in a book. You can literally count these, and you can tell me how many students are in the course or how many pages are in the book. Versus continuous variable is also going to be a quantitative variable, but this one has an infinite, so non-countable number of possible values. These are usually a measurement, such as time, temperature, weight, and height. So the next example that we have says determine whether the variable is discrete or continuous. So the first example that we have says the number of apps that you have on your phone. And even if you have a lot of apps on your phone, you're still able to count those. And since you can count them, this is discrete. Next we have is the length of a baseball game. And since we're talking about time, this is a measurement. So it goes into seconds, it goes into milliseconds, nanoseconds, and so forth. So if this is an example of a continuous data. Part C says temperature of any randomly selected day in the city of Walnut. And since we're talking about temperature, and again, that's a measurement, this is also an example of continuous data. Part D says home runs hit by a baseball player. And since we can count these, they're whole numbers, this is also going to be an example of discrete data. And then part E says life expectancy of a person. So when we talk about life expectancy, this is also going to be a measurement. So this is continuous. The level of measurement of a variable, we have 4 different classifications. The first one that we have is nominal. If the value of a variable's name, label, or categorized in addition to the naming scheme does not allow for values of a variable to be arranged or ranked in a specific order. So if a variable is nominal, then we can check to see if it is ordinal. Ordinal is going to be if a variable has the properties of a nominal level of measurement. However, the variable is arranged in or ranked in a specific order. And then if a variable is ordinal, we can check to see if it is interval. It says if the variable has the properties of the ordinal level of measurement, however, the difference in the values of the variable have meaning, arithmetic operations such as adding and subtracting can be performed on values of the variable. And then if the variable is interval level of measurement, we can check to see if it's ratio level of measurement, which is going to be if the variable has the properties of the interval level of measurement and the differences in the values of the variable have meaning, and there is a natural zero starting point. Also, the ratios of the values of the variable have meaning. So with this, the way to kind of think about this is to start at the top and work your way down. And so nominal is pretty much anything would have a nominal level of measurement. And then ordinal is going to mean that you can put these in some kind of specific order and it makes sense. So the key thing here is that it has to be placed in some kind of specific order, whether it's numerical or alphabetical, but some type of order that makes sense. The next one that we have is interval, which is where we can do arithmetic operations, and the big one here is difference. So where you could subtract them and it makes sense. Again, that key part there is subtracting them to make sense. If something's alphabetical order, you can't really subtract those and it makes sense. However, if it's a numerical ordering, you can subtract them and a lot of times it will make sense. Then the last one that we'll try, so if it is interval, we can check to see if it's ratio. And for this one, this is going to be that there is going to be ratios and they're going to have some kind of meaning. So again, ratios is something where you would be dividing, and when you divide those, it makes sense. We also have that has a natural zero starting point. So it would have a value that would be 0, and that would be the starting point for those data values. So on the next page, we have some examples that we're going to look at. And again, I'll work my way through these for each example. So the first one that we have on here is going to be, the example says determine the level of measurement of each variable. Part A says birth year. So starting with nominal and working our way down. So again, everything is nominal. So the next one that we have is going to be ordinal. So can we put these in order, in a specific order, and it makes sense? And yes, you can go from youngest to oldest or oldest to youngest, and it makes sense. So the next one that we're going to check is then interval. So right now it has the ordinal level of measurement. So let's check interval. This one is going to be that there is a difference between the values and it makes sense. So if I were to say that one of my daughters is born in 2009 and another one is born in 2010, we can subtract those and see that there's a 1 year age difference, and that makes sense. That has a meaning in regards to the problem. And so right now we're at interval level of measurement. So then we check for ratio. And so ratio is where you would divide these and write it as a ratio. And so if we were to divide, let's say that 2009 divided by 2010, we get a weird decimal that doesn't really have any kind of meaning for us. And so we know that it would not be a ratio level of measurement. Therefore, the farthest that we could go would be interval. The next example that we have is marital status. Again, everything starts with that nominal level of measurement. Ordinal would mean that we can put it in some kind of order and it makes sense. For marital status, again, this is married, single, widowed, divorced, separated, so forth. And so what order would you put them in that makes sense? What would go first? There isn't really any order that you could have for these that would make sense. So this would be an example of nominal. Part C says letter grades of all students in a statistics class. Again, make sure you guys realize that this is letter grades. And so again, everything starts off in nominal. Part C says letter grades of all students in a statistics class. And again, this is letter grades of all students in a statistics class. So again, everything starts off being nominal, level of measurement. Ordinal means that you can put these in some kind of order and it makes sense. Being letter grades, we can rank them from highest to lowest or lowest to highest. So either A to F or F to A, and that would make sense. Checking for interval, subtracting those letters, it doesn't make any sense to our problem. A minus C, I don't know what that would mean. So we would stop and go back at, okay, it was satisfied at ordinal level of measurement. And then part D says the height of K through 12 students. So again, for part D, starting at nominal, which everything has, and moving to ordinal, and you could put these in some specific order and it makes sense, whether it being shortest to tallest or tallest to shortest. Interval will be where you can subtract those heights and they make sense. So again, saying I have a 6-foot student and a 3-foot tall student, subtracting those, I can see that there's a difference in height by 3 feet. So far has the interval level of measurement. Next one we check is ratio. So for ratio, this is where we would be able to divide. And so if we were to divide either way, but let's go ahead and say 6 divided by 3, 6 feet divided by 3 feet. When you divide 6 divided by 3, you get 2. And so you can see that that one student, the 6-foot tall student, is twice as tall as that 3-foot tall student. And so because of this, we have an example of ratio. And it also says a natural zero starting point, which again, with the fact that we're dealing with heights and a height being of 0 would be your starting 0 value. The next section that we have is section 1.3, which is collecting sample data. We have a lot of vocabulary words again that you should have memorized for your next exam. First vocab word is the response variable. A quantity that we ask a question about is the response variable. We have a placebo, which is a harmless medication like a sugar pill that looks, tastes, and smells like the experimental medication. Gold standard, which is randomization with a placebo and a treatment group. An experiment, a treatment is applied and then the effects are observed. The individual in the experiments are called experimental units, and they're often called subjects when they are people. Next is treatment. This is the factors, an explanatory variable or an independent variable manipulated by the experiment. We have a control group, a group of subjects or conditions that is matched as closely as possible to an experimental group, but does not get exposed to any experimental treatments. So this is what we use to compare. And then we also have what's called a placebo effect. This is an individual subject believes that they received the treatment, and so they might act a certain way because they believe they're receiving that treatment, when in fact they're actually given a placebo. An observational study is we observe and measure specific characteristics, but do not attempt to modify those individuals being studied. So an observational study example would be something like you're sitting there and observing to see if people are stopping at stop signs completely. Whereas an experiment is where you would give them a specific drug or a certain task that they have to do, and then observing how they behave after that. So the next example that we have says determine whether the study is an experiment or an observational study and identify the major problem with the study. So part A says in a survey conducted by USA Today, 1,465 internet users chose to respond to the question posted on the USA Today electronic edition. Is news online as satisfying as print and TV news? 52% responded yes. So the first question is asking about, is it an experiment or an observational study? And since we're just observing what people say and writing that down and not giving them any kind of treatment, this would be an observational study. And then it also asks for what is the major problem with this study. So the issue with this study would be that it is a convenience sample, and we are asking for people to respond to this question and not collecting an accurate sample of our population. Part B, an independent researcher tests the effectiveness of Atkins weight loss program by randomly selecting 1,000 subjects using that program. Each of the subjects was called to report their weight before the diet and after the diet. So we are giving this group of people a treatment, and that treatment is this Atkins diet. And so because of that, this is called an experiment. And again, that treatment would be the Atkins weight loss program. And the issue with this is going to be that people are self-reporting their weights before and after. And this is a problem because people might lie about how much they've lost, or if it's working or if it's not working. So self-reporting is definitely a problem here. At the bottom of page 4, we have some additional definitions. And so we have blinding. This is going to be a subject does not know if they receive the treatment or the placebo. Double blinding experiments are going to be neither the experimental unit nor the researcher in contact with the experimental unit knows which treatment the experimental unit is receiving. Replication is the repetition of an experiment on more than one individual. Randomization is used when individuals are assigned to different groups through a process of random selection. And then we also have a simple random sample, and we actually abbreviate this, as you're going to see this quite often, as SRS. And this is a subset of N individuals, a sample chosen from a larger set, capital N, which is our population, and each individual of the subset has equal probability of being chosen. Next page, we have another example. The example says, in an experiment in which blood pressure medication is tested, Group A is given blood pressure medication, while Group B is given a placebo pill. The two groups do not know which medication that they were given. However, the researchers do know. What is the treatment? What is the control group? And what kind of blinding experiment is this? So our first question is, what is the treatment? And the treatment is going to be the blood pressure medication. And the next question says, what is the control group? And the control group would be the group that is receiving the placebo. And since the two groups that we have is group A and group B is given the placebo pill. So this would be our group B. And again, the reason why is because they are receiving a placebo pill, which is not any of the medication. It's just a sugar pill, looks, tastes, and seems like the same thing as the one that group A is getting, which is actually the blood pressure medication. And then it also tells us what kind of blinding it is. So it tells us that the two groups do not know which medication that they're given. However, the researchers do know. And so because of this, this is blinding or single blinding, you will also see it as. And this is usually the case. The next example that we have says the plant ginkgo biloba has been used in traditional medicines for thousands of years. Doctors and researchers of this man and his colleagues want to figure out if ginkgo could be used to safely treat symptoms of dementia caused by Alzheimer's disease or multiple strokes. In this placebo-controlled, single-blinding experiment, 309 subjects were either given daily ginkgo extract or a placebo, and were followed for the next 52 weeks. So part A asked, what does it mean that the experiment is placebo-controlled? And one of the issues with statistics is that there is so many different ways to word things. And so, again, placebo-controlled was not a definition that we were given. However, this problem is discussing that. And being placebo-controlled would be that some subjects are going to receive a placebo. So are going to get a placebo. And others get the actual medication, which is that ginkgo biloba extract. Part B says, what does it mean for the experiment to be single-blinded? And we kind of used this in the last example, but single-blinded is going to be that the subjects don't know what they receive, but researchers do. So part C says, what is the population for which this study applies? What is the sample? So we have our population and then our sample. So let's go ahead and look at the sample first. And so we know that the sample is going to be, it tells us 309 subjects. And we know that they all have dementia, which is caused by Alzheimer's. So this is going to be those 309 subjects, and they're actually adults, it does say up there, with dementia caused by Alzheimer's. So a lot of times students can easily classify the sample. However, what is the population? So the population, remember, is where this subset is coming from. And so it's not 309 people. It's going to just be adults. All adults, right, with dementia caused by Alzheimer's. So next question, part D, says what are the treatments? And it does tell us that they were given daily ginkgo extract. And it also tells us that they were given this for 52 weeks. So for 52 weeks. Part E says what is the response variable? And it also asks for, is it quantitative or qualitative? So for this, what is the response variable? And so the response variable would be treating symptoms of dementia, and is this quantitative or qualitative? And we don't exactly know what they're doing, but they're most likely asking them questions and how much they're remembering and things along those lines. So I will say that it is going to be qualitative. So next thing that we get into is different types of sampling methods. So the first one that we have on here is stratified sample. This is separating the population into non-overlapping or mutually exclusive groups. We call these strata, and then obtaining a simple random sample from each stratum, so from each group. The individuals in each stratum should be homogeneous or similar in some way. The benefit of stratified sample over simple random samples is that it may allow fewer individuals to be surveyed, yet still obtaining the same or more information. An advantage of stratified sampling is that you can determine characteristics within each stratum. So the next example that we have says ASB at a local high school wants to determine the student's opinion on a recent assembly. They divide the school into grade level groups. The school has 572 freshmen, 523 sophomores, 491 juniors, 437 seniors. The ASB director wants to survey 100 students with the number of individuals selected from each stratum weighed by population size. What are the different stratums in this survey? So again, those stratums are going to be how individuals are going to be placed, and they have to be similar in some type of way. And so for us, it's going to be by grade level. So it's freshmen, sophomores, juniors, and seniors. So the different stratums are going to be freshmen, sophomores, juniors, and seniors. So again, by grade level. The next type of sampling method that we have is systematic sample, and this is obtained by selecting every kth individual from the population. The first individual selected is going to correspond to a random number between 1 and k. And the benefit of systematic samples is that it doesn't require a frame, so you don't need a list of individuals in the population. So the next example that we have says a local hardware store decides to survey every 5th person who leaves the store. The owner randomly selects a number between 1 and 5, and let's say 3, so that way we're all doing the same problem. And it says determine which customers the survey will include. So again, the first person that we're going to survey, we select is 3. And we are going to survey it tells us every 5th person. So to go to the next person, we need to add 5. So the next person that we're going to survey is number 8. So the 8th person to leave the store. And then to get to the next one, we're going to add 5. So 8 plus 5 is 13. So the 13th person to leave the store. And then to get to the next person, we're going to add 5. We get 18. So the 18th person to leave the store. And I think you should get the hang of this by now. We're just adding 5 because it's every 5th person. So the 23rd, And I'll just put ... And this can go on until that store owner feels like they've collected enough data, or for the day, or maybe for the week, whatever it is that this store owner decides he wants to do. The next type of sampling that we have is cluster sampling. And this is where you divide the populations into sections or clusters, and then randomly select some clusters and choose all members from the selected cluster. So we're going to choose some clusters, survey all, that's our big word here, for the members from that selected cluster. A lot of times students get cluster sampling confused with the one that we had first, which is going to be that stratified sampling, just because we're splitting things into groups. But remember, stratified, you put them in groups where they have some kind of similarity in between them. And then you're going to select some from each of those groups, each of those stratums, versus down here with cluster sampling, we're going to divide into clusters, and it doesn't say anything about them being homogeneous or the same in some way. And then we're going to have them broken into clusters, and then we're going to choose all members from a cluster. So everybody in group A versus a little bit from group A, group B, group C. The next one that we have is convenient sampling. And this is a sample in which individuals are easily obtained or self-selected. And it's not based on randomness. For example, phone-in polling, internet surveys, solicitors at a store, and these results are unreliable. And we've seen that already, and we talked about that. And the last one that we have is multi-stage sampling, which we don't see too much of in our textbook, but it is another option. And this is going to be collecting a sample in different stages, and then each stage might use a different method. Determining the sample size is key in overall statistical process. Researchers need to know how many individuals need to be surveyed in order to draw conclusions about the population from its finding. Realistically, the main determining factor of sample size of an experiment are determined by the amount of time and money that the researcher company has. So the next example that we have says, assume that the population consists of all students currently in your statistics class. And for simple purposes, let's go ahead and just say we have 36 students, which is not correct, but let's just assume. And it says, describe how to obtain a sample of 6 students. We want a sample of 6 students so that the result is a sample of the given type. And I want you guys to realize that there's a lot of different answers for these. So if you ever have any questions about yours, please reach out and ask. So the first one that we have is a simple random sample. And so I don't know if you guys have ever had a class where they put names on maybe a deck of cards or popsicle sticks or just some index cards, but they will randomly select 6 of those from the class. So I'm going to say randomly select 6 sticks with students' names on them. The next example that we have is the systematic sample, which is selecting every so many person. Since we need to have a sample of 6, and I gave us 36 students in our class, we can select every 6th person that enters the class. So select every 6th person that enters the class. The next one that we have is stratified samples. And stratified sample says where we have to divide these into groups, and those groups have to be homogeneous in some way. So we can say we can divide them into 2 groups or 3 groups or 4 groups, and we can do this based upon political affiliation. So we can divide class into groups, which is going to be Republican, Democratic, or independent, so whichever one you more likely would relate to in views. And since we have 3 different groups here and I need a total of 6 students, we are going to select 2 randomly from each group, each political affiliation group that we have. And again, that simple random sample, so maybe you have sticks with everyone's name on them and select 2 from the Republican group, 2 from the Democratic group, and 2 from the Independent group. The next one that we have is going to be cluster samples. And why don't we divide, I'd say everybody find a partner. So students get into pairs. And so everyone has a partner that they're working with. So we can easily do that in class. And our 36 students, that works out really great. So we have groups of 2. And since I need 6 students, I'm going to select 3 pairs. So students get into pairs, and we are going to select and randomly select, we can say, select 3 groups of pairs. And then the last one that we have, E, is a convenience sample. And for this one, since I need 6 students, I might just ask you guys to raise your hand. To volunteer. And again, there's other methods for these. So there are different ways, different things that you can do. Maybe instead of for convenience sampling, I might ask you guys to email me if you're interested in volunteering. Or stay after class. Again, cluster samples, we can do groups of 3 or groups of 6 are usually the best ones for this type of problem. And then stratified, you don't have to break them into groups based upon political affiliation. You can break them into groups based upon gender identity. You can break them into groups based upon age. You can break them into groups based upon number of units that they have so far at Mount SAC. And systematic sampling, that one we kind of need it doesn't have to be that enters the classroom, but every 6th person works out really nice for this problem, but could be every 6th person alphabetically or something like that. The next example says, determine the types of sampling that is used. The author collected sample data by randomly selecting 5 books from each of the categories of science, fiction, and history. The number of pages of the books were then identified. And so we are breaking these into groups. Those groups are going to have them broken into science, fiction, and history. So they all are homogeneous in some type of way. And it also says that sample data by randomly selecting 5 books from each of the categories. So breaks them into these groups and then selects a little bit or 5 from each category. And so because of this, we have a stratified sampling method. Part B says during the last presidential election, CNN conducted an exit poll in which specific polling stations were randomly selected and all voters were surveyed as they left the premises. So right now things are broken into the polling stations. So we have them in groups, and it says that they were randomly selected and all voters were surveyed as they left the premises. So not a little bit from each one, but all from these. So broken into groups and selecting everybody from that group. Again, that was called our cluster sample. And these are the 2 that students get most confused. So make sure to look at the differences between stratified and cluster sampling. Below this example, we have some additional vocab. We have a completely randomized design. This is going to be each experimental unit is randomly assigned to its treatment. We have matched pairs design, which we're going to see quite a bit of. And this is an experiment design in which the experimental units are paired up. The pairs are selected so that they are related in some way. There are only 2 levels of treatment in a matched pair design. It's usually before or after or twins. We also have a randomized block design. It is used when the experimental units are divided into homogeneous groups called blocks. Within each block, the experimental units are randomly assigned to a treatment. We have different types of errors also. So there's 3 different types of errors. Non-sampling errors result from undercoverage, non-response bias, response bias, or data entry errors. We have sampling errors. This results from using a sample to estimate information about a population. This type of error occurs because the sample gives incomplete information about a population. And then we also have a non-random sampling error. This is the result of using sampling method that is not random, such as using a convenient sample or voluntary response sample.